talked about solving equations with variables on both sides. When you have equations like that, sometimes weird things can happen. Sometimes you end up with no solution at all. It's not even possible to answer the question. And sometimes you end up with an equation where no matter what number you put in, it's going to work. So any number could work as a solution to your equation. That's what we're going to see today. So the solving process for something like this looks the same as just a normal equation with variables on both sides. But what's different is at the very end, your answer is going to look a little bit funky. So looking at this equation, I'm going to just solve it like normal. I look at the left-hand side and I'm going to simplify as far as I can. Then I look at the right-hand side and simplify as much as I can. Then we solve. So on the left, the first thing I see is that I can distribute the negative 5. So negative 15x plus 20 minus 12. And then on the right, I might as well distribute that as well. I can distribute the 4. I get 8 minus 16x plus x. Keep simplifying. I did the multiplication, so now I go into any adding and subtracting. I see a couple like terms, 20 and negative 12, and then negative 16 and positive x. Those are two terms that I can combine. So I combine them. And now I go ahead and get all my variables on one side. So on the right-hand side, I've got that negative 15x. If I want to move that whole piece from the right over to the left, I need to add all 15x's. So we have minus 15x. I need to add all 15x's, so those cancel. But on the left, you see that the same thing happens. Negative 15x, if I add 15x, that cancels. So on the left-hand side, the only thing still there is an 8. And on the right, I have an 8. Well, this is true, which means your equation is actually always just plain true. It doesn't matter what x value you put in, your equation will always be true. So what we say for this is that there's actually infinitely many solutions. So that's an example of solving an equation that has infinitely many solutions. I hope that helped, and I'll see you next time. Bye.